on custom live streaming and hope it works.
Looks
Is it
good.
working?
Mhm.
Okay. Sorry for all the people watching on YouTube who the first 3 minutes is just me going, is it working? Okay, so you should all be set. So I will mute and turn my video.
Thank you, Huda. Okay, it is 1 o'clock Eastern time. Welcome, everyone. Just a reminder, we have some important links here, which I will drop in the chat, in the Zoom chat shortly. Please visit our conference website, review our code of conduct. If you are supporting the conference on social media, no matter what social media you use, please tag hashtag LD4_2023. If you have missed the Slack invites, they will be linked below as well. And you can watch our live streams on YouTube or refer to this link to check out the recordings for the sessions you may have missed or want to revisit. Thank you for joining us for From Ambition to Go Live, the National Library Board of Singapore's journey to an operational linked data management and discovery system. We are joined by Richard Wallace. Richard is a UK-based independent consultant focusing on linked data and structured data on the web. Working with the W3C community groups, including schema.org, and having 3 decades of experience in the cultural heritage sector, he has participated in many interesting and challenging projects. His most recent is with the National Library Board of Singapore, which is the subject of today's presentation. Thank you so much, Richard. We'll turn it over to you.
Hi there. I hope people can hear me, and they may even be able to see me at the moment. Welcome from the United Kingdom. Let me share my screen, which should be appearing now. Yes, I am sharing the screen according to Zoom, and we all trust what Zoom tells us, don't we? Right. Thank you for that kind introduction. As you can see, we're going to be talking about a journey the Library Board of Singapore took to deliver a new product in their environment, and I was part of that journey. For those that don't know me, just a brief overview to get my PR out of the way early on. I'm an independent consultant, evangelist and founder of my own consultancy called Data Liberate. I've been around computing an embarrassingly long time. I feel very old putting up numbers like this, but I've been in computing for a long time, 3 decades associated with cultural heritage technology. And the last couple of decades promoting the semantic web and linked data and schema.org and similar. Associated with many W3C community groups, especially around cultural heritage, but not exclusively, involved in tourism and financial and educational interests. I work with various organisations. I work with Google. Please note I said the word with, not for Google, around their contribution to the open schema.org community, around its vocabulary and maintaining its site, adding extensions, documentation, etc. Cultural heritage, I've worked with a former employer of mine, OCLC, financial industry, and various individual clients, helping them implement and understand linked data and schema.org. One specifically pertinent to this presentation is the National Library of Singapore, but others include over the years British Library, Stanford University Law, Europeana, etc. So that's enough about me. A bit about the National Library Board of Singapore and my acknowledgements to my colleagues on this project from the National Library Board who provided some of this information. At a really high level, they're interested in readers for life, learning communities, and a knowledgeable nation. It's all around providing value to the citizens of Singapore and Singapore as a nation, which resulted in a mission to make knowledge come alive, spark imagination, and create possibilities. They do this in various guises. They host a network of 28 public libraries in Singapore itself, with the usual public library initiatives around exhibitions and programs targeted at Singapore communities. They run out of this architecturally stunning National Library, and it's well worth a visit. I did a presentation in that room on the very top, which was quite impressive once the view's excellent. But in that building, they preserved the nation's print and literary heritage, reference collections and legal deposit. They also have responsibility to helping the information from the National Archives reach the wider world. So that's got the nation's history and heritage, management of public and private archival records, etc. And in doing this, they've kind of amassed a lot of stuff. Over 5 million print collection, 2.4 million music tracks, etc. Things like 8,000 e-learning courses, newspapers, magazines, etc. They also have a reference collection with over 500,000 Singapore and Southeast Asian items, social sciences, rare materials, particularly in Singapore relevant Chinese, Malay and Tamil language items, etc. And then from the archival side of things, they've got well over 1 million photographs, 70,000 maps and building plans, speeches, 35,000 oral history interviews, which is an interesting collection. So they're very into preserving the history of Singapore and where it came from. So to make this visible to the outside world, one, as you imagine, has several public access interfaces. The obvious one is the public access catalogue that services the 28 branch libraries and the library within the National Library itself. They have a portal that provides access to the art items that they manage and host. They have something they call Infopedia, which is kind of a Singaporean Wikipedia, an online encyclopedia about anything of interest in Singapore, from buildings to people to events and subjects, etc. They run History SG, which is a history portal focusing on history resources, which is you can search for individual items, events, or explore themes through the history of Singapore. They have a music portal, Music SG, which provides access to their online music collection. They run an online electronic journal called Biblioasia, which they host. And they also have a site managing pictures that are relevant to Singapore. Some of them light-hearted, some of them historically relevant. And as I say, they've also got responsibility for making visible the archives from the National Archives of Singapore. So as you can see, like a lot of organisations like national libraries, they have lots of resources and lots of ways to get at them. They have these individual portals that tend to be, in search terms, silos of access, if you like, into the environment. So this led to the ambition that is referred to in the title of this presentation. The first ambition was to enable the discovery and display of entities from different sources in a combined interface, to bring together resources, physical and digital, and to bring together diverse systems across the National Library, National Archives and public libraries in a linked data environment. So this ambition is all about bringing stuff together, bringing it in together so they can feed it in if you like, a single fire hose to the population around. But on top of that, they need to provide a staff interface to this to view and manage all the entities, their descriptions and relationships. And notice in the ambition, they use the phrase linked data, which raises the obvious question, why linked data? Well, what they discovered over the years that flat record-based systems are difficult to integrate. Anybody that's tried to integrate disparate systems that are based on record formats find it both difficult and fragile if you succeed. They want to move away from traditional keyword search to discovery of resources known and unknown. Some element of serendipitousness, if that is such a word, in the discovery of items. They want to take advantage of the benefits of knowledge graphs, more expressive to show relationships, and flexibility in mashing data together. And they want to provide a natural interface for sharing data on the web. Linked data in the data format kind of emulates the linked pages in the internet via the web, which enables people to navigate in a familiar fashion, if you like. And then all the advantages identified in previous projects. I've had the privilege to be working with the National Library of Singapore on various projects for over 5 years now, and from investigating the benefits of schema.org to creating prototype triple stores based on early BibFrame vocabularies, through to exposing bibliographic records on the web and experimenting with how Google and other search engines discovered them and linked to people. It came fairly obvious that this is the kind of way to go forward. So the journey started. The journey started in March 2021, quite mundanely, with a option to tender for a project to deliver a linked data management system, the LDMS as they christened it. It needed to be a cloud-based system. They didn't want a room in the National Library full of servers going whir and heating the building up. They wanted a management interface to deliver control and functionality over this environment. But he had to cope with the fact that the source data for this system is curated still at source. The library system items are curated in the library system. The authority data are curated in a system that they call TTE. You might hear me call that TTE during this presentation. It's authority data that's relevant to Singapore and the National Library. They curate data in a content management system, which drives some of those disparate portals I showed you earlier on. And the National Archives data is unsurprisingly curated by the National Archives. So it needed to be linked data. It needed a public interface to use the phrase Google friendly or search engine interface friendly, which was crawlable by them and understandable by them, which brings in the implicit need for schema.org in the interface somewhere. It needed to use shared standards wherever possible. They didn't want to reinvent wheels. And in the community, in the library community, and is blatantly obvious from this conference, there's a lot of shared understanding and discussion about linked data. So it meant that where possible, we could use vocabularies that are standardly used in this environment, which implicitly means BibFrame and schema.org. The next step in the journey was the contract was awarded. It was awarded to a consortium with 3 members. The main player is an organization from Germany called Metafax, and their main product is something called the Metafactory platform, which is a low-code knowledge graph platform and semantic knowledge modeling and semantic search and discovery platform. And by low code, I mean it's easy to build products and interfaces to those products. The second member of the consortium was an organization called QMAN, Singapore-based organization, Amazon Web Services partner, public sector partner in Singapore, and they actually have experience on other projects dealing with Singapore government projects. And last but not least is a consultancy called Data Liberate, i.e. me, who brings to the project linked data, structured data, semantic web, bibliographic metadata, schema.org and data management system experience into the project. So when, excuse me, when the consortium got together, there was some initial challenges. The first one, data, lots of it. all in record-based formats. We've got MarcXML coming out of the integrated library system, out of the content management system and the National Archives system. We've got Dublin Core XML, and out of TTE, the authority system, we got a bespoke version of content separated format. And those records describe entities. So, for example, a MARC record is going to give you information about a work, an instance, possibly an item, various people and organizations as authors, curators, publishers, etc., subjects, material types, all sorts of entities that are embedded in the flat MarcXML data, and similarly for other formats. Because we're bringing in data from the systems that are managing live sites, that data is changing, and those changes need to be regularly updated into the linked data management system that we're building here. On a daily basis, the integrated library system is outputting delta dumps of any changes. Content management system, roughly weekly, the National Archives and the authority system roughly monthly, which basically means you're not going to get somebody sat at a desk spending their life manually importing files. We need an automatic ingestion system to take care of these dumps, to actually import them into the knowledge graph. One of the major challenges, and I've hinted at it before, is we're not the single source of truth. We are an aggregation of the several sources of truth from the source data. So we may be hopefully a single source of access eventually, but we're not the single source of truth. We also need the ability to manually update and curate the data in the linked data management system, and having an entity-based search and discovery system and a web-friendly, i.e. schema.org output. So to enable us to do this, we had to create a data model within the system, which is linked database, using BibFrame as a vocabulary to capture detail of bibliographic records coming in the MarcXML form, schema.org to deliver structured data for search engines, schema.org representation of the CMS, NAS and TTE data, and schema.org enrichments to BibFrame. So this basic model means that schema.org has become the lingua franca vocabulary of the knowledge graph, meaning that all entities describe schema.org as a minimum. We may well have other terms in there, and for the records that are coming in from the ILS system, we've got all the BibFrame data as well. But when putting the interfaces together and navigating the data, we can guarantee that any entity we deal with will have schema.org data, which it makes modeling and building systems around it a lot easier to work with. I talk about data and data. Just a quick reference that from the ILS, there is 1.4 million records, content management systems, 82K, 1.6 million records from the National Archives, and 3,000 records from the authority system. So that gives us 3.1 million records to play with. But if you then start exploding the entities out of those records, you suddenly start getting much bigger numbers. So the 1.4 million records from the integrated library system are actually describing 56.8 million entity descriptions. And I won't go through the other numbers, but if you come down to the total, we're dealing with 3.1 million flat records, which explode out to 70 million entities to deal with within the system. So how do we get this data into the system? We ingest it from data ingest pipelines, one pipeline per source, integrated library system, content management system, National Archives, and the TTE authority data. So let me look a little bit more into the details of these pipelines. So this one is the integrated library system pipeline. Source data comes in Mark XML files. The first step is to use Mark to BibFrame 2 scripts. These are open source scripts shared by the Library of Congress, which to a certain extent have become a bit of a standard approach. There are variations on this, but this is the, if you like, the de facto standard that you start with. And it outputs BibFrame as individual Mark XML files, RDF XML files, sorry. So for every Mark record we get, we're outputting from this first step an RDF XML mini graph, if you like, of the relationships to the entities that are described within that Mark record. Step 2 is using a script called BibFrame to schema.org script. It's an open source script shared by the BibFrame to schema.org community group, which coincidentally I happen to be chair of. It's a Sparkle-based script which goes through the RDF XML BibFrame, identifies the entities and the relationships, and introduces schema.org to enrich those entities, and then output the BibFrame with schema.org enrichments into individual RDF files. So what we're using is 2 open source scripts that are then wrapped in a management environment, which unpack the Delta dumps, identifying within the Delta data, are we talking about a new record that's being added and a current record that's being modified, or records that are being deleted, and direct the data to the appropriate script ready for loading into the knowledge graph triple store. Looking at the TTE authority system, source data in a bespoke CSV format, exported in collection-based files. So we get one file for people, one for places, one for organization, time periods, all sorts of things. But however, we discovered when we started on this project, there are interrelated references between these files. So we had to consider it as a whole. And in fact, the process that manages the ingest of TTE takes a full dump so it can map these interrelated references. And that was built using bespoke Python scripts. The output is a schema.org entity descriptions in an RDF format file ready for loading into the knowledge graph triple store. The National Archives system and content management system are treated very similarly. The source data is in XML files. The first step is to take these flat Dublin Core XML files and translate them into a graph of entities and terms defined using Dublin Core Terms RDF. This is done using a bespoke XSLT script to translate from the flat record to the Dublin Core's Term RDF. The step 2 is very unique, and there are quite a few unique things in this project, not only in the ambitions, but the implementation. But one of the unique steps here is that there are elements within the Dublin Core, especially from the content management system, that reference terms that are authorized terms in the TTE authority term. So the second step is to look at values within the Dublin Core that have been identified as lookupable, if there is such a word, lookupable items. And for those individual items, which we only receive the string name of, we look up against the knowledge graph, which already has previous versions of TTE loaded in it, looking for a match of the right type. If there isn't a match, we just store the string name that we started off with. If there is a match, we store the URI of the entity within the knowledge graph. So we're even at import stages, we're assigning relationships between different data sources based on URIs. The final step is schema.org entity creation. So the DC Terms RDF mini graphs for each item that have been looked up against TTE and enriched with URIs, and then run against a Sparkle script to create a schema representation of the DC terms which are then output in individual RDF format files to loading in the knowledge graph. There's a bit of a pattern here. The pipelines take flat files, do their pipeline specific stuff, and then produce RDF files for loading directly into the knowledge graph. So how is this actually implemented? Here's a technical architecture simplified. I wouldn't want to put up the full diagram. You wouldn't be able to read it, but it's hosted on Amazon Web Services. So the foundation of all this is a knowledge graph, a traditional triple store based knowledge graph. Partnering with the project is an organization called Ontotex, and we're using their commercial GraphDB clusterable knowledge graph system. And in the production area, we're running five node GraphDB. Then we have a hosted version of MetaFactory from MetaFax, which is building the public interface for public access. We also have another MetaFactory instance separately. They share a lot of the code from the original source area, but it's a separate instance designed for managing curator access into the data. We have a standard Linux-based virtual system in Amazon Web Services for running batch scripts and controlling imports, etc. And it is that area that automates the import of source data from source systems. And we take advantage of serverless computing from Amazon Web Services. So we use the AWS Lambda Python capability, so that if a Python script needs running, we just take a serverless instance of that script, which means if there's no processing going on, there's no resources being used. If there's lots of processing going on, it scales up to many, many instances of Python processing. This is all managed from the batch scripts and import control, etc. So there's interaction between the source data that's being imported and the Lambda services. And then these data are then transferred into the GraphDB cluster. And then the two MetaFactory instances, one for discovery interface and one for the data management interface, then interact with their data. So how's this deployed? That was a sort of technical diagram, if you like. How's it deployed? Well, it's deployed in the Singapore government on commercial cloud feature. They call it GCC. And this is a secure wrapper to Amazon Web Services with very strictly controlled access via VPN and other services to the services in that environment. And this government compute cloud is not just for the National Library project, it's for all government departments within Singapore. So you can imagine what the security is like in that environment. So in that environment is deployed a production environment. The architecture that I've just described is deployed with a 5-node GraphDB cluster. There is also, in a separate area with slightly more relaxed access, is a staging environment which is used for testing updates, testing changes, diagnosing issues, etc., and for curator training. Now that architecture is deployed with a single node GraphDB, as the performance requirements are obviously not so stringent in that environment. And then finally, there's a development environment which the partners to this project run in standard Amazon Web Service environment with access for development and support teams. And that again has got a single node GraphDB instance. So the flow of development or updates, etc., is it's developed in the open dev environment that the partners can all access. It's then transferred to staging, where it's tested and acceptance tested by first the development partners, then by the National Library Board staff. And when only when that has passed, do changes then get transferred under the guise of GCC staff into the production environment. So That's, if you like, the technical challenges. What about the data challenges? Well, look, I keep saying, and it's true, there's lots and lots of data. There's no single source of truth. We need to be able to reconcile entities. You know, you will pick a person described in one MARC record and they'll be described in 15 other MARC records, and also in the content management system, and maybe there's an authority record that matches them. We need to be able to reconcile those together. So we needed an adaptive data model to cope with the reconciliation of these entities that are being poured into the system. So we need to deliver, if you like, a discoverable and shareable tip of this iceberg of data. I refer to a need for reconciliation. Zooming down into it a little bit, you know, there's lots and lots and lots of source entities, as I was saying earlier on, there's 70.4 million of them. There's lots of duplication. Here's an example. So here's Lee Kuan Yew, first Prime Minister of Singapore, is mentioned in 160 individual MARC records, and therefore at source data level, there is 160 individual ILS source data entities. Another example is Singapore Art Museum, an organisation. Entities from the source data, there's 21 entities that are created from the content management system, 1 from the National Archives, 66 for the integrated library system, and in quite a relieved way, there's only 1 from the authority system, so that's good on the authority system. But the point is, users discovering data only want 1 of each of these. So we have the challenge of 70.4 million does go into 6.1 million entities that are discoverable. Now, we know that now because we've developed the product, but how did we get there? The requirements hurdle, to be clear, were firstly, again, I keep emphasizing this, we're not the single source of truth. We're also not a static data set. On a daily basis with imports from various source systems, the source data and the entities created from it is actually being updated. We need manual management of the combined entities that appear, if you like, at the searchable peak. And this includes suppression of incorrect or private attributes. A good example of this is the author that doesn't want you to display their birth date for various reasons. Or it may be that one of the entity from source is describing an attribute of an entry incorrectly, and we want to be able to suppress that. We need to be able to add attributes to entities that are not coming in from the source data. So the curators may well know some information about an entity and must be able to add it. No reconciliation system is going to be perfect, unless even if you do it with human beings, but definitely an automatic system is not going to be perfect. So we need manual ability to create relationships between entities that the curators know is exactly the same real world thing, and be able to break relationships between, for instance, 2 organizations with the same name that are actually separate entities. And we need to do all this in near real time. We don't want to be a month behind before the data is queued. Ideally, within a 24-hour period of an update coming in from source data, it needs to be visible in the linked data management system. And the kind of edits we're talking about here are about adding attributes. It needs to be fairly instant. So I talk about these data model. The data model concepts consists of 3 layers. We have source entities, individual representation of source data created via the import pipeline. We have aggregation entities, and these are entities that you use to track the relationships between source entities for the same thing. This is not copying attributes around, it's just tracking links between associated entities. And finally, we have the primary entity layer, which is the layer that's searchable by users, displayable to users, and is a consolidation of aggregated source data and any managed attributes suppressed or added. So this is often viewed better visually. So what I'm looking at here, we're in the data management interface in one of the attributes that comes, functional attributes that comes with the MetaFactory platform, which gives you a visual display of the relationships between entities. So I've focused in on here, I've picked the Singapore Art Museum as an example, and this is the primary entity, the entity that's searchable and displayable to the outside world. So if we look at its properties and its relationships, we can see it's aggregated by 4 of these reconciliation entities. Excuse me. So there's one for each data source. There is one for the ILS, one for the content management system, one for the National Archives, and one for the TTE authority data. So what we can do is see what they aggregate. And I know you can't see it, but I know from experience that this first one I'm looking for is in the National Archives system, and this second one is in the TTE authority system. So let's move things around. I need a bit more screen space, so I'll let this video move on a little bit so that we're in a position to display what I'm looking for. So, okay, so let's go and have a look what the content management system is aggregating. It's aggregating 21 source entities that have been created by importing lots of flat records from the content management system, and they're aggregated in this aggregation entity, which then goes to help the consolidation of the primary entity. Moving on a little bit more, let's have a look at the ILS data and see what we've got here. And this is aggregating 66 references to entities created from MARC records that reference Singapore Art Museum, whether it be a subject or an owner or something or whatever. So as you can see, this gives you a very visual view of the data that's being aggregated together within this system. One little wrinkle, you notice near the bottom right-hand corner of the screen, it's labeled one of those entities as Agent 710-21. Which is a URI that's been allocated to the source entity and its creation. I deliberately stopped the video at this time because one of the attributes of this functionality within MetaFactory is it will auto look up names if you let it do. So it's displaying that entity with that URI. But if I move on a fraction, it is now translated that to Singapore Art Museum. It's automatically looked up the name attribute from an entity, which makes it a lot easier to work with data in this system. So I talk about matching these entities to aggregate them together. So how do we match them? Candidate matches are based on schema names. Remember me saying the minimum requirement is every entity must be described using schema.org, which means we know that every entity will have a schema.org name attribute. We use inbuilt Lucene indexing within the OntoText GraphDB system to match entities together to come up with, if you like, candidates of potential matches together. We then refine the process with some Levenshtein similarity matching, plus obviously we're going to match organizations to organizations, not organizations to people or places or whatever. So it needs to be of the same entity type. And then some entity type specific rules are applied. So if we're looking at a work entity, we need a match on the name plus a match on the creator or a contributor or an author or a same as relationship. Similarly with a person, we need to match on the name plus either a birth date, a death date, or a same as relationship before them, we bring them together. So this hierarchy brings together what I keep talking about is the entity iceberg. But the tip of the iceberg, which is what the public access of this system is designed for, is the primary entity, which then drives discovery interfaces, etc. The next layer down are these aggregation entities, which just map relationships that then aggregate the source data, which is being updated at irregular intervals by the ingestion pipelines. And because of the way the aggregation works, when we touch a record, imagine for an update, the source data will change, which triggers a reconciliation process to make sure the aggregation entities are in line, and then the consolidated view into the primary entity is updated. And this is managed by the data management interface. Let's have a look at the data management interface, which has been rapidly developed and easily modified in the Metafactory platform, using the Metafactory semantic visual interface. It's a collaboration environment for data curators. From the beginning, it was realized that several curators may be working on the same entity. So there's the ability to pre-publish what's going to happen if you press publish on an entity, and then the curators can interact with each other in the environment. Search and discovery in the data management interface emulates the discovery interface. There's a dashboard view. It allows entity creation and it allows entity management. Let me take you through a video of a change being made in the data management interface. So we're doing discovery interface emulating lookup. The display is not quite the same, but the discovery process is the same. And we're looking at the information panel for this record. And particularly for this example, we're highlighting the birth date, the birthplace, and the death date. Note the birth date and the death date have two values. One a year only, the other a year, month, day, more accurate version. So let's see what a curator would do to manage this. We come through into the management interface for this entity, and you can see we've identified the single year birth date, and by pressing a simple button, we're then suppressing that data from the public interface, and we're doing that for the same single entity for the death date. Going down to the birthplace, we can see this birthplace is Jamaica, which we don't want. So we suppress that. And then we enter more accurate birthplace information. And this person was actually boarded on a ship off the coast of Jamaica. So we then save that data, which enables us to take a look into the preview of what the record would look like. Sorry, what the entity would look like if it's changed. Notice the modified label at the top of the screen. That's telling the curator these changes have not been published yet. So you can see we've suppressed the two attributes in red. We go down the page a little bit and see the birthplace. We can see we suppressed the Jamaica reference and added in a new curated reference for onboard ship Anne. Then when we do publish, we enter a comment around publishing. So when other curators want to know what we've done and why we've done it, we've got a reference so they can communicate via the system. And it's now published. And then it's viewable in the discovery interface. So let me take you through to a discovery interface screen for the same record. It's bringing in, because we're in the knowledge graph and the references around it, it's bringing in an image from the content management system. Let me view more details. You can see the changes we made to the birthplace, the birth date, and the death date are displayed in the discovery interface in the way we want them, because the attributes we didn't want to display, we've suppressed. and you can see external links that have come in from other sources. At the bottom of the page, we've got references to this person. So we've got works by Thomas Raffles, contributions to works by Thomas Raffles, and works about Thomas Raffles. Let's have a quick look in the works by Thomas Raffles. You can see there's a work here, A History of Java. If you click through, we get to the work page and open up below a version instance with a link through to the library, and very often you'll get various versions of different format types linked below the work. If we click on one of the about relationships, which is a subject, and I picked on Indonesia Java, you can see that Java on the subject of Java was written by John Pemberton. If I click through to there, we've got the work display for that particular work. Traditional linked data navigation, very web-like in the discovery interface. So we implemented all this, and the LDMS system went live in December 2020. It went live from a data curation point of view, the curation team using the DMI for entity creation, and they actively merging and splitting aggregations. It went live from a data ingest point of view. Regular imports and update deltas coming from source systems, daily, weekly, and monthly, with delta update exports from the source system. It went live from the point of view that the discovery information interface was ready for deployment, and it went live from support. So since December 2022, the partners in that delivered this are actually supporting it with issue resolution, diagnostics, and updates. Talking about the discovery interface, as I say, it's live and ready for deployment, and it's been performance and load tested. But it was designed and developed by the NLB data team to demonstrate characteristics and benefits of a linked data service. NLB services are rolled out by the National Library itself and the public library divisions, which are different from the data services team, who have now recently identified a service for linked data integration, and the discovery interface is currently undergoing fine-tuning to meet the services UI requirements, and the DI as a whole, or aspects of the DI, are hoped to be made publicly live fairly soon. I talk about daily delta ingestion and reconciliation. Here's an internal graph we use to monitor data imports in the system, and this goes from the 23rd of December 2022 up until a date last week, and you can see on practically every day there is some form of data ingestion going on, with some fairly large peaks. Somebody with a keen eye will spot all those peaks are limited at 25,000 items per day. The reason for that is we want to make sure that we don't overload and affect the performance of the system by bringing in too many inputs. So we limit it to 25,000 a day, and any more than the 25,000 is then rolled over onto following days totally automatically. So if we get a big peak, it might take a couple of days to clear, but it's automatic in that. The project, as I say, was delivered by several partners, and it's delivered in a global form. You've got down there in the bottom right-hand corner, for those that are geographically aware, Singapore, where the system is implemented, and the Cuman team are based. But we've got developers involved in the project from Indonesia, and various times in the project there was people from St. Petersburg in Russia, people in Turkey, people in Germany where Matter Factory is based. There's myself in the UK, where there were people in Ireland, and we've still got people on the team that are located in Ecuador. A definite global spread of development and interaction. And we use common modern tools like Skype for intermediate, instant interaction, Google Meet for meetings, Google Docs for sharing spreadsheets and documents, etc. Lots of emphasis on regular meetings, weekly meetings, daily meetings. It's developed in the cloud so everybody can get at the development environment without having to jump through too many security hoops. It was an iterative development developed using an agile approach And I'm fairly confident if this was designed in detail on day one, it probably would have taken 3 times as long to deliver, because a lot of the answers are only available once you start looking at the problem in detail. Some challenges along the way. Inaccurate source data was one of them, not apparent in the source systems, but very obvious when aggregating in the LDMS. For example, we found that some URIs being allocated to persons were also being allocated to subjects. So in this example here, we've got a person entity who's got a name of Lee Kuan Yew, which is fair enough, but he's also got a name of Lee Kuan Yew biography, Lee Kuan Yew poetry, and this is where duplicated URIs have been instantiated in the system. These were identified and analysed using the data management interface, reported to source curators who fixed it, and then updated in the next Delta update. So this is where the LDMS, as well as providing its own service, is actually helping to improve the data quality of source systems. Another one here is Asian name matching was a challenge. Often Asian names of people and places, etc., consist of several short 3 to 4 letter names. Lucene is not very good with lots of short words and not much help, which is where the Levenshtein similarity matching was introduced to help. Tuning this was challenging. You would find that you'd improve the matching of Southeast Asian names, but then start over reconciling with European names. So it became a little bit of science, but there we go. So a summary of a large complex project. It started off with an ambition based on previous years of trials, experimentation of understanding linked data, an ambition to deliver a production library management, linked data management system to provide linked data curation and management capable of delivering a public discovery service, but with experienced commercial partners. So Metafactory, myself, and Cuman brought years and years of experience to the project, but where appropriate, benefiting from open source community. Unique, challenging environments with distributed sources of truth, disparate data formats, auto-updating, consolidated entity views, plus individual management, web-friendly, providing structured data for search engines. Live and operational today, actively delivering the benefits from December 2022 onwards. And that's in slightly longer than I estimated, is a description of this ambitious project from the National Library Board of Singapore. And I want to rest my voice a little bit now. So have we got any questions, etc.?
Thank you so much, Richard. That was a fantastic and super informative presentation. We do have quite a few questions for you. I'm going to start with the earliest question. We received a couple from Huda. She's asking that assuming when you say 5-node GraphDB clusters, you mean nodes in the sense of cluster nodes and not RDF nodes?
Correct.
Excellent. And then she follows up and asks, apologies if you've already elaborated on this, but in your architecture diagram, you have 2 separate Metafax icons, one for the discovery interface and one for data management interfaces. Are these 2 separate interfaces on the same backend or 2 entirely different Metafax systems?
There are 2 instances of the Metafactory systems on separate devices. They operate in the same way. They share a lot of the same code line, but one has the responsibility for providing public discovery access, which in the secure environment in the Singapore Government Compute Cloud, it is only that instance that is accessible by the outside world. And then we have a separate instance which is there for the curators to manage the data. They're both looking at the same knowledge graph, but for performance sharing and security of access, we implemented it with 2 separate instances of the Metafactory toolkit.
Thank you so much. We have a question which asks, will the information updated and corrected by the DMI, by curators be shared back with the source data?
No. There isn't a continuous loop in that, because by the time you've aggregated up to a primary entity, you're pulling data from many sources. You only have to look at the Singapore Art Museum example, where it's cascading in from nearly 100 entities, etc. And at this stage, we're not rerouting that data, but the data services team closely interact with the library management system team, for instance. So if they found an interesting fact that they added via the LDMS management interface, I think they might use traditional mechanisms like email to highlight that information might be added to the integrated library system.
Thank you. Huda asks, just wanted to confirm, are the aggregation entities a result of the reconciliation steps you outlined? These are entities that are supposed to represent the same entity based on the similarity algorithms you are using?
Yes, that's correct. So when we get an entity that's been introduced into the system, say a person entity, the first step in the reconciliation process is there an aggregation entity that I match with? If not, I need to create one. If there is, we just build a relationship between that aggregation entity. And then if the aggregation entity has changed, we then reflect that up with consolidation up to the primary entity level.
Thank you. We have 2 more questions. Are there plans for usability testing, or has there already been some usability testing done on the Discovery interface specifically?
Yes, the public Discovery interface has been usability tested within a closed focus group, if you like, within the National Library, and it has also been tested and exposed to other organisations within the National Library Group that manage these services, so they can see what's available and discuss the best way to integrate that functionality and that capability within the how can I put it, landscape of systems there are at the National Library.
Okay, with apologies, we actually have 2 more now.
Okay.
Were there situations where the data conflicts could not be resolved given the multiple sources of truth?
Yes. But the resolution, if you can't match correctly, you end up creating a new aggregation entity. So you don't end up with orphan source entities. They're all related to an aggregation entity. So what happens then, and it's usually when you're in a public interface or you're looking in the data in the DMI, you'll suddenly find 2 entities that look the same, but for some reason they haven't been aggregated together. And that's where the manual aggregation processes to come together to be able to merge those 2 disparate aggregations together that couldn't have been aggregated together because of various lookup challenges between data sources, or indeed within data sources.
Okay, and this will be our last question, among a lot of appreciation for this talk in the chat. John writes, entity reconciliation between text strings in different separately managed systems is a very hard problem and virtually impossible to automate with 100% precision when you have large pools of data. I'm impressed with the reconciliation you've described. Did you have to do any special case processing for highly recognized entities like Lee Kuan Yew, or was there general tuning and testing against cases like that sufficient?
I agree with the opening statement to his testament. It's not easy. I can assure you it's not easy. I used to have a lot more hair. No, we found we could get close enough. And with the ability to report back challenges to source systems, where, for instance, they've got typos in data and things like that, it improved over time anyway. But we did identify that there are ways that this didn't work fully automatically, but it became obvious in the data management interface. The challenge hadn't been fully accepted by the automation within the system, which is why there's been a lot of emphasis within the data management system in the how do we break reconciliation merges that are wrong or create ones that should have happened, etc. And at the moment, it seems that the curation team are kind of happy with that approach to it. There's no special case requirement, because by the time you've identified a special case requirement, you're already in the data management interface, so you can manually correct it at that point. And those corrections will remain even if the underlying source data changes, because of the consolidation approach to delivering a consolidated primary entity, which is bringing together all the entity descriptions through the hierarchy we've described, but then laying on what the humans have done manually on top.
Thank you so much, Richard. Unfortunately, we're at time, but thank you again for this presentation, and we'll continue talking in Slack. Thank you again, everyone.
It's been a pleasure.